The continuous function f is defined on the interval -4 is less than or equal to x is less than or equal to 3. The graph of f consists of 2 quarter circles and 1 line segment. So this right here is 1 quarter circle, then we have another quarter circle, and then it has this line segment over here, as shown in the figure above. I put the figure on the side so that we have some screen real estate down here. Let g of x be equal to 2x plus the definite integral from 0 to x of f of t dt. All right, that's a little bit interesting. Now let's do part A. Part A, find g of -3. So we want to find g of -3. So first of all, they tell us what g of x is. So g of -3, every time we see an x, we just put a -3 there. So it's going to be 2 times -3, 2 times -3, plus the definite integral from 0 to -3, f of t dt. So this first part is pretty straightforward. 2 times -3 is -6. And then this part right over here is the definite integral from 0 to -3 of f of t dt. So from 0 to -3 f of t dt. So this is essentially the area under f of t, or under f of x, if you want to view it that way, from 0 to 3. And this is pretty straightforward to figure out, but we have to be careful here, because this area right over here, this would be the integral. Let me do this in a color that you can see. That area right over there would be the integral from -3 to 0 f of t, or we could either say f of t dt or f of x dx, either way, dt. That would be this area right over here. They've swapped it. They have the larger number as the lower bound. They have 0 as the lower bound. So what we could do this, we could rewrite this. This is the same thing. This is equal to -6 minus, if you swap the bounds of integration, you've swapped the sign on the integral. So we could say minus from -3 to 0 of f of t dt. And now this thing right over here, this expression right over here, is the area. It is the area under this quarter circle. And the area under this quarter circle, we can just use a little bit of geometry to figure that out. We know its radius. The radius here is 3. Radius is equal to 3. The entire circle is pi r squared. So the entire circle, the area, if this was an entire circle right over here, if this was an entire circle, that area would be pi r squared, so pi times 3 squared, so 9 pi. So it would be 9 pi, but this is only 1/4 of the entire circle, so we want to divide it by 4. So this right over here will evaluate to 9 pi over 4. So part A, we get, it's equal to -6, that's that right over there, minus 9 pi over 4. And that's at least the first part of part A. Then they say find g prime of x. So let's find g prime of x. So g prime of x. We did the first part of part A right over there. Then we need to find g prime of x. G prime of x, well, it's just going to be the derivative of g of x. The derivative of 2x is just going to be 2. And then the derivative, and this is the fundamental theorem of calculus right over here, the derivative of the definite integral from 0 to x of f of t dt, that's just going to be f of x. That is just going to be f of x. So that is g prime of x. We did this second part right over there. That is g prime of x. And then we need to evaluate it at -3. So g prime of -3, g prime of -3 is going to be equal to 2 plus f of -3, which is equal to 2 plus, and let's look at let's see what f of -3 is. This is our function definition. When x is equal to -3, our function is at 0. So f of -3 is just 0. So it's just 2 plus 0, which is equal to 2. So g of -3 is equal to 2. And we're done with part A. And the trickiest part of this is just realizing the bounds of integration. That you might be tempted to say, oh, the integral between 0 and -3, that's just this area over here, because we're going between 0 and -3. But you got to realize that we actually have to swap them and make them negative if you really want to consider this area right over here. That this integral is going to be the negative of this area. And that's what we did when we went to this step right over there.